On a summer evening in 1996, a routine international flight prepared to cross the Atlantic.
Later, investigators would carefully analyze radar data to understand what happened next.
At John F. Kennedy International Airport, preparations for departure were routine and uneventful.
Passengers gathered at the gate, preparing for an overnight flight to Europe. Boarding began as scheduled, with no reported issues.
Passengers boarded through the jet bridge, unaware of what lay ahead. Inside the cabin, preparations for departure continued as usual. Throughout the aircraft, the atmosphere remained calm and routine. In the cockpit, the crew followed standard pre-flight procedures. All systems appeared normal.
With boarding complete, the aircraft pushed back from the gate. The flight prepared to taxi for departure.
The aircraft began taxiing toward the departure runway.
Inside the cockpit, standard taxi procedures were completed.
The aircraft paused briefly before entering the runway.
The aircraft lined up for departure on runway 22R.
Clipper 123, taxi to runway 27 right via taxiway Alpha. Be advised, heavy regional jet traffic on final approach.
The aircraft lifted off and began its climb. The takeoff roll began under normal conditions. The flight climbed away from New York, heading east. Inside the cabin, the flight settled into its climb.
Flight data showed a normal climb profile. No anomalies were recorded at this stage.
The flight continued its climb over the Atlantic.
Multiple radar systems continued to track the flight.
The cabin remained calm as the aircraft climbed.
Inside the cockpit, flight conditions appeared normal.
From the outside, the flight appeared steady and uneventful.
Air traffic control observed no irregularities.
The aircraft continued along its planned route.
Flight instruments continued to show normal conditions.
Moments later, events unfolded that would change aviation history.
Radar data later showed a sudden and unexpected change.
The aircraft was no longer visible on radar.
Investigators later replayed radar data, frame by frame. Controllers began reviewing what they were seeing. Search operations began shortly afterward. By morning, the search expanded across the area.
An extensive investigation was launched.
Investigators reconstructed sections of the aircraft to understand the sequence of events. Recovered material was carefully documented and analyzed. Attention soon turned to what had happened inside the aircraft. Attention turned to the conditions inside the fuel tank. Electrical wiring became a key area of examination. Investigators began focusing on the aircraft's fuel system. The aircraft's systems reflected standard industry practices of the time. Tests were conducted to understand how ignition could occur.
Investigators examined how fuel vapor could become flammable.
The concentration is increasing right here.
Electrical separation standards were carefully reviewed.
Multiple experts were consulted during the investigation.
The findings would later influence aviation safety practices.
The investigation moved toward its final conclusions.
After months of analysis, investigators began consolidating their findings.
Analysis indicated the breakup began within the aircraft structure.
Investigators determined the initial event occurred inside the center wing fuel tank. Multiple scenarios were tested to understand possible ignition mechanisms. Attention turned to possible sources of ignition energy. Some details could not be determined with certainty.
The investigation led to changes aimed at improving safety. The investigation closed, but its influence did not.
News of the accident quickly reached audiences around the world.
Local communities felt the impact deeply. The memory of those lost continues to be honored.
The investigation contributed to lasting improvements in aviation safety.
Fuel tank safety standards have since evolved.
Commercial aviation continues with a stronger focus on prevention.
For investigators, the case left a lasting professional impact. Flight continues, informed by lessons learned.
The ocean returned to stillness.
Aviation safety is written in lessons learned. Investigators documented every step for future reference.
Independent experts later reviewed the investigation's conclusions.
Independent experts later reviewed the investigation's conclusions.
Regulatory agencies reviewed the findings carefully.
With Reading 24 Exploder wind models. The investigation challenged long-standing design assumptions.
Maintenance training standards were strengthened in the years that followed.
Electrical inspections became more detailed and systematic.
Every investigation leaves a lasting mark on the system.
A broader culture of safety awareness took hold across the industry. Aviation continues forward, guided by lessons learned.
Modern aviation relies heavily on continuous data analysis.
Aviation safety increasingly depends on shared responsibility.
Modern aviation relies heavily on continuous data analysis.
Fuel systems are now monitored with greater precision.
Electrical protection standards were strengthened industry-wide.
Regular audits now play a central role in prevention.
Thousands of flights now cross the same skies each night.
Passenger safety remains the industry's central commitment. Each departure carries the weight of past lessons. Aviation safety is a process that never truly ends.
Research continues to refine how risks are identified and reduced.
Each investigation informs how future investigators are trained.
Modern safety planning relies on predictive risk modeling.
Manufacturing processes now emphasize layered safety checks. Maintenance planning now focuses on early detection.
Redundancy reduces the chance of single-point failure.
Safety systems are continuously reviewed and refined.
Aviation safety standards are shaped through international cooperation.
Most flights today proceed without incident.
Passenger safety remains the industry's central responsibility.
Each day begins with renewed commitment to safety. Safety is the result of many systems working together.
The environment remains unchanged, but understanding deepens.
Millions of flights operate within an interconnected global system. Scale demands discipline.
Safety depends on responsibility at every level.
Every investigation adds to a larger body of knowledge.
The skies remain active, shaped by experience and learning.
Operations continue around the clock.
Aviation safety continues to advance, flight by flight.
Reflection is part of progress.
Safety is reinforced through daily decisions.
Attention to detail reduces uncertainty.
Training evolves as understanding deepens. Safety emerges from systems working together.
Routine reflects reliability.
Every flight follows disciplined procedures.
Safety is felt through trust and consistency.
Safe outcomes are the goal of every layer. Safety is built quietly, flight after flight. Safety work continues long after most flights have landed. Every aircraft rests after fulfilling its mission. Every investigation becomes part of aviation's permanent memory. Lessons learned are passed forward to future professionals.
Every day begins with renewed responsibility. Routine operations reflect disciplined systems. Aviation moves forward through understanding.
Perspective shapes responsibility. Some lessons are written into the horizon itself. Understanding replaces uncertainty. Silence allows reflection. Aviation safety is built on lessons that are never forgotten.